Welcome back. We are going to discuss concepts based on gravitation, mechanical properties of solids in this session. First, gravitation. Gravitation lesson contains Kepler laws, factors affecting acceleration due to gravity, orbital velocity, escape velocity, and energy of a satellite, uses of artificial satellites. These things we are going to discuss. Kepler's laws of planetary motion. The very first one, Kepler laws. Yes, there are three laws. Law 1, law of orbits. Law of orbits. Every planet revolves around the sun in an elliptical orbit, being sun at one of the focus, right? So that is law of orbits. Every planet revolves like this, and the point which is very close is called perihelion point, and the point which is very far is aphelion point, right? Next, law of areas. Radius vector joining the planet and the sun sweeps equal areas in equal intervals of time, or aerial velocity of the radius vector is constant, and you need to know this formula, L by 2m. L by 2m. People get confused with kinetic energy of rotational system, L square by 2I. That is different, this is different. Aerial velocity is L by 2m. Aerial velocity is L by 2m. This is L by 2m. This is constant. That is important here. Next, remind things are normal. This is a consequence of law of conservation of angular momentum. Next, law of time periods. Every planet's time period is, okay, some other point is coming here. That is 1 plus c by 1 minus c point this is. That means if the closest point is a into 1 minus c is the closest point, and the farthest point is a into 1 plus c. So from law of conservation of angular momentum, v1 r1 is equal to v2 r2. That only this one. Next, law of periods. T square proportional to r cube for every planet. Time square of time period proportional to cube of radius. Next, Newton's law of gravitation. Newton's law of gravitation is a universal law. Every body in the universe attracts every other body. Every body in the universe attracts every other body with a force F, which is equal to g m1 m2 by r square into r cap with a negative sign. Why? Because r cap will be in this direction and attraction force is in this direction. So negative sign will come, and g value 6.67 into 10 power minus 11 nm square per kg square. Next, gravitational force acts on the two bodies. One forms action, other one will be reaction. So both are equal. Even though one is bigger and smaller, don't think that the smaller one will experience more force and the bigger one will experience less force. Both will be equal. Whenever apple is falling onto the earth, force exerted by the apple is equal to force exerted by the earth. But you are noticing only apple's motion but not the earth's motion. But both the forces are equal and opposite and in same magnitude. So coming to the next one, gravitational force is independent of the medium. Very, very important. Electrostatic force and magnetic forces are dependent on medium. That medium constant is permittivity for electricity, permeability for magnetism. But here this force is independent of the medium, and law of gravitation is a consequence of action at a distance concept. Relation between small g and capital G. Small g is equal to gm by r square in terms of density. Whenever you are observing options in terms of density, just we are changing mass into volume into density. That will be 4/3 pi r g rho. 4/3 pi r g rho, and weight always related to acceleration due to gravity. At different places on the earth, different g value will be there, different weights will be there. And variation of g with altitude. If you go some higher heights, altitude means height, then acceleration due to gravity decreases. That we are going to have an expression, gh is equal to gm by r square. R is the distance between the point and the center of the earth, and gm by r plus h whole square. small g into r by r plus h whole square. If h is very small, then only you can use this formula, that is g into 1 minus 2h by r. Where is that? Yeah, that expression may goes to the another page. H into what you call 1 minus 2h by r, g into 1 minus 2h by r. That is for only small heights, not for all the heights. That yeah, that I didn't find here. I'll write here so that you can follow. Okay, what is that? Let me take up a color pen, and this one's it takes time to write first time. Yeah, so that is GH. Let me use another color. GH is equal to G into 1 minus 2h by r. This h very small only, otherwise you shouldn't use this. This is a specific formula only for shorter distances. Okay, next, variation of G with depth. Variation of G with depth. GD is equal to G into 1 minus d by r. It is true for everything, and G is equal to 4/3 pi g r rho. Next, fractional decrease is change in G by G, that is equal to d by r. And variation of G with distance from the center of the earth is characterized like this: straight line inside the earth, outside rectangular hyperbola. Right, or hyperbola, because r square is there, hyperbola. If it is 1 by r, then rectangular hyperbola. Next, variation of G with latitude is G phi is equal to G minus r omega square cos square phi, where phi is the latitude. Latitude picturization will be like this. Latitude will be like this. Suppose this is the earth and this is equator, and if you are here, then this is called latitude phi. That means this is north pole, this is south pole. Imagine it's a sphere, okay, whatever earth size. If you are here, what will be G value? G phi is equal to G minus r omega square cos square phi. That is the formula. And time period of the earth rotation T equal to 2 pi root r by G. If time period becomes that much instead of 24 hours, if it is 84 minutes, roughly 84 minutes, then what happens, the persons at equator will feel weightlessness. That concept only this is. And this angular velocity of the earth is 17 times the current angular velocity. 17 times the current angular velocity. Variation of G according to the shape of the earth and local conditions. Of course, suppose heavy concrete buildings and mineral reserves presence increases G value. Attraction force increases, and other things will be so and so. Next, and poles are closer because earth is bulged, and equator is farther. Obviously, at equator G value lesser and at poles higher. Next, orbital velocity V0, orbital velocity. What is the orbital velocity formula? V0 is equal to root over gm by r plus h is the orbital velocity. V0 is equal to root over gm by r plus h. Orbital velocity equal to root over gm by r for a surface satellite. Surface satellite means height is very lesser. Then h can be neglected, then it will be gm by r, that is root gr. This is only for surface satellite. Its value is, orbital velocity for surface satellite is 7.98 kilometers per second, not kilometer per hour, kilometer per second, remember. Next, simply 8 you can feel. Next one is orbital velocity of a satellite is we are discussing. Angular velocity is square root of gm by r plus h whole cube. This is angular velocity. So time period is 2 pi root r plus h cube by gm for that particular orbiting satellite. And then energies will be potential energy minus gmm by r, kinetic energy gmm by 2r. Kinetic energy never negative, it's positive because of mv square, so it's always positive. Total energy is minus gmm by 2r. Kinetic energy, potential energy are going to have what you call 1:2 ratio. Kinetic energy lesser, half, to potential energy, and kinetic energy value, total energy value will be equal. Kinetic energy, total energy values are equal. Okay, and their ratio is 2:1:-1. Angular momentum of a satellite, L equal to mvr, that is equal to, this is the expression root over gmr square r. This is angular momentum of a orbiting satellite. For a satellite in height of the orbit from the surface of the planet, then its potential energy increases, kinetic energy decreases on increasing the height. If you increase the height, potential energy increases, kinetic energy decreases, orbital velocity decreases, total energy increases, period of revolution increases. Important points. Vice versa, if you decrease, reverse things will happen. Okay, and next, from law of conservation of energy, this is actually suppose a body was projected with velocity v from the earth's surface at an angle theta with the horizontal, then v1 be the velocity of the body at the maximum distance r1 from the center of the earth. Then from law of conservation of angular momentum, mvr cos theta equal to mv1 r1. For numerical problems calculation sake, this will help you. Conservation of angular momentum you can use always. Next, if a satellite revolves in the direction opposite to the earth rotation, if a satellite revolves in the direction opposite to the earth rotation from east to west in the equatorial plane, omega dash is equal to omega s plus omega e, t dash equal to ts te by ts plus te. So very useful formula for problem solving. If two stars of masses m1 m2 radii r1 r2 separated by distance small r, then the minimum speed of projection of the body from the surface of one star towards another should be sufficient to cross the null point. The null point is x is equal to r by square root of m2 by m1 plus 1. What is the null point distance? X is equal to r by square root of m2 by m1 plus 1. Next, apply law of conservation of energy at the surface of the first star and the null point will come automatically. It's a derivation for the null point. Don't waste your time at this moment. Escape velocity to escape from the gravitational field, we need to supply an velocity square root of 2gm by r. That is gm by r for the surface satellite, orbital velocity. This is escape velocity, and this is equal to root 2gr, and escape velocity equal to root over m by r or r root rho. Escape velocity proportional to r root rho. Escape velocity for the moon is 2.38, earth is 11.2, sun is 42 kilometers per second. Yeah, escape velocity. Next, g value 610 times g value actually. It depends on the mass and radius of the planet, and it is independent of the mass and the direction of the body, whatever you are trying to project. And escape velocity, surface satellite orbital velocity relation is VE is equal to root 2 into V naught. Next, if the speed of the orbital satellite is made some number of times increased by 41.4%, its kinetic energy is doubled. Next, for a satellite V less than V naught, then what happens? It revolves in an internal elliptical orbit. If V is equal to V naught, it revolves around the earth in circular orbit. Excellent point it is. If V naught is in between, that means the velocity of the orbiting satellite is in between V naught and VE, then revolves in external elliptical orbit. Next, V is equal to VE, it escapes. Good points, these are all. Next, gravitational force experienced by unit mass is known as gravitational field strength. I is equal to F by M, just like electric field strength, that is F by Q. Magnetic field strength, F by M. This is also I is equal to F by M. And I is equal to Gm by R square. This is not small m, this is, okay, here small m I kept, so small m, okay, fine, no issue. Next, location of null point, that is M1, M2 are there, then gravitational field will be 0 at x is equal to same square root of M2 by M1 plus 1. Next, the resultant gravitational field strength for multiple masses is E bar is equal to E1 plus E2 plus E3. And E versus graph will be like this. See, E is nothing but I is nothing but here E versus, this is not E, this is I only. I versus R is electric field and gravitational fields are similar, so that's why we use that word. I is equal to Gm by R square is the formula actually. I equal to Gm by R square. Very similar to acceleration due to gravity. So acceleration due to gravity is analogous means similar to gravitational field intensity. Gravitational field intensity and acceleration due to gravity at one point are same, no doubt. Next. So that graph, only this graph, no need to prepare another graph. All the formulae are similar and same. Done. Next. Gravitational field strength due to uniform circular ring. Gravitational field strength due to uniform circular ring is this expression. And the respective things, mass of the ring, radius. Actually, these things you can practice from electricity and you can impart to it. So that will be easy. And gravitational field strength is maximum at r by root 2 distance on the axial line, on the axis. Okay, diameter by 2 root 2. Important bit in electricity, right? That only. Next, for sphere point. Next, gravitational field strength due to a thread of mass of density lambda kg per meter at a distance r is given by 2g lambda by r sine alpha plus beta into r. Linear mass, massless object, linearly massless object, just like gravity, electricity. Next, this is the picture. This line, straight line, is having mass. And at a distance r, we are going to find out gravitational field intensity. The expression is 2g lambda by r sine of alpha plus beta by 2. Next, gravitational potential. The amount of work done in bringing unit mass from infinity to a point is gravitational potential. Point in the gravitational field. The amount of work done. Okay. Next, it is always negative because it automatically comes. You no need to do any work. It only liberates work. Negative work, that's why negative potential. Yes, and the maximum value is 0 at infinity. Gravitational potential maximum at infinity, that is 0. Gravitational potential at a point due to point mass is minus gm by r, just like electricity only. It's always negative because always attractive system and it liberates mass. And inside the earth at a distance r, gravitational potential is not same as the surface. It's a solid sphere. So minus gm by 2r cube into 3r square minus r square. Remember, on the surface minus gm by r, and there will be a graph. Otherwise, I'll give. Yeah, this is the graph. Actually, the graph you have to treat in the downward direction. Why? Because it's a negative one. You have to treat like this. You print this in your mind like this. That is like this. This is potential negative. This is positive, and this is r. Okay, this and this will as follows. Next. The gravitational potential at a point due to spherical shell inside will be same, just like that one only. Inside and on the surface, gravitational potential will be same, minus gm by r minus gm by r. Outside, minus gm by small r. So first learn electricity and then you can correlate. Okay, next. This is the graph for shell, inside same, but remember it is negative. So treat that it is a negative axis and it's a positive axis. That's why they kept v on the downward, on the top minus v. That you need to put in your mind. Gravitational potential at a distance r from the center of on the axis of the ring of mass m and radius r is given by Vr is equal to minus gm by square root of r square plus r square. Next, relation between gravitational field and potential. Gravitational field and potential, gradient of v, that is E is equal to minus dou v by dou x into y, dou v by dou y into j, dou v by dou z into k. Or v is equal to integral dv, that is nothing but integral e dot dr. V is equal to integral e dot dr, infinity to r. Gravitational potential energy. Energy formula already we have taken, minus g m1 m2 by r, that only this one. U equal to minus g m1 m2 by r, gravitational potential energy. And change in potential energy also will come here, minus mgh by 1 plus h by r. Let me read out this. The potential energy on the surface of the earth is minus gmm by r. Minus sign you need to maintain, minus gmm by r. minus, because gravitational potential energy always negative only, right? Next, that only minus mgr, and at a height minus gmm by r plus h. Here also minus sign. Minus is merged in the by. Okay. Next, potential energy at the center of the earth is minus 3 by 2 gmm by r. It is not 0. Potential energy at the center of the earth is minus gmm by, that is minus 3 by 2 gmm by r, not 0, remember. Work done in lifting a body from the surface of the earth to a height h against the gravitational force is gmm h by r plus h, or mg h by 1 plus h by r. This only I wanted to say. Suppose a body is raised through a height h, then work done is equal to, people usually write mgh. If h is small, we can write mgh. Otherwise, you have to write mgh by 1 plus h by r. Remember. So in 8th class, we teach small things. But here, you are going to learn the real things. Self-energy. Self-energy of a massless system is minus 3 gm square by 5r is the self-energy of a sphere. And self-energy of a thin spherical shell is minus gm by 2 gm square by 2r, because mass into mass is itself. So m square will come. Geostationary satellite whose time period is 24 hours is a geostationary satellite. Its time period 24 hours. A parking satellite. Relative to Earth, its velocity is 0 relative to Earth, and its height is 36,000 kilometers. From the center is 42,400 kilometers. It revolves from west to east in equatorial plane. Polar satellite, which covers the poles, and a satellite whose orbital plane is perpendicular to equatorial plane is called polar satellite, since its time period is around 100 minutes. It crosses any altitude many times a day. The angle between the equatorial plane and the orbital plane for a polar satellite is 90 degrees. Weightlessness, if g equal to 0, this is separate concept, weightlessness. If effective g value 0, then we'll call weightlessness. An object appears weightless at the equator if Earth's angular velocity becomes 17 times and g value less than r omega square. Object flies off from the surface of the planet, g value greater than r omega square, then it get attracted to that planet and stick to the planet. And we are going to discuss mechanical properties of solids concepts from now onward. The lesson structure contains types of strain, types of stress, Hooke's law, elastic moduli, Poisson's ratio. We are going to discuss in this session. Potential energy of a system of two molecules at a distance of separation r is U is equal to A by r to the power of P minus B by r to the power of Q. A, B are constants. Force interaction between two molecules is F is equal to minus du by dr. Stress is restoring force per unit area, that is F by A, F by pi r square. For a hollow cylinder of inner and outer radii R1, R2 placed vertically on a horizontal surface, stress at the bottom is, and is given by stress. I have a hollow cylinder of inner and outer radii R1 and R2 placed vertically on a horizontal surface. Stress at the bottom is, stress is equal to force by area, right? Force by area is pi r2 square minus pi r1 square, that is force by pi r2 square minus r1 square. This expression should come here, it is missing. A uniform rope of mass m length L is pulled by a force F at from one end. The stress at a distance x is from the end where force is applied is F by A into 1 minus x by L, where A is cross section area. Shearing stress and longitudinal stress on the section AB inside the rod when force is applied on the rod on either sides is given by stress is equal to F sin theta cos theta by A. F sin theta cos theta by A. Tensile stress is F by A sin square theta. This is tensile stress. This is shearing stress. Shearing stress will be different direction. Tensile stress will be different direction. Okay, restoring force developed per unit area. Breaking stress. Breaking stress we are going to discuss here. Yeah. We are discussing stress only mainly here because strain is having less number of formulae. What are they? Suppose strain is equal to change in dimension to the original dimension. This is strain. So strain is also having three types: longitudinal strain, bulk strain, volumetric strain. Strain has no units. These are important things. And I would like to say one more related point for the strain, that is, suppose coefficient of expansion is equal to change in length to the original length into temperature difference. Then strain, we will call it as thermal strain. Thermal strain is equal to alpha into L delta theta. This is thermal strain. And one more thing, suppose a body is changed some percentage, say X percentage. Suppose one body is changed X percentage, then strain is equal to delta X percentage, I told, right? So delta L by L into 100 is equal to X. So strain delta L by L is equal to X by 100. These points we are going to discuss under strain. Now coming to the stress. Breaking force by initial area, whatever we are going to take up. Maximum length of the wire that can be hanged without breaking under it will be breaking stress by rho g. Length L is equal to breaking stress by rho g. Rho is the density of the material. And here Young's modulus Y is equal to longitudinal stress by longitudinal strain, FL by AE. And if a load M is attached at the lower end, then Y is equal to mgl by pi r square E, where R is the radius of the wire. And pi r square is the cross section area of the wire, but not the suspended sphere radius or something else. Be careful in that. A load is attached to the wire and immersed completely in a liquid, then elongation is given by mgl of 1 minus rho L by rho B by AY. Next, a load is partially immersed in a liquid, then elongation is mg 1 minus volume of the body inside the liquid into rho G into L by AY. Relation between Young's modulus and the interatomic constant is K is equal to YR naught, where R naught is interatomic distance and K is interatomic constant, Y is Young's modulus. Next, two wires are connected in series. E is equal to E1 plus E2 is follows total elongation, that is equal to, that follows as Y values also you can, that in the next step it will come, I think so. F1 is equal to F2, restoring forces will be same among, provided the mass comparatively lesser, mass of the wire comparatively lesser to the applied force. So L1 plus L2 by Y effective, that is L1 by Y1 and L2 by Y2. If L's are equal, then Y effective is, when two wires are connected in series, effective Y value is 2 Y1 Y2 by Y1 plus Y2. If two wires are connected in series, effective Y is 2 Y1 Y2 by Y1 plus Y2 if lengths are equal. Next, if two wires of same length are connected in parallel, then effective Y value is Y1 plus Y2 by 2 if the cross section area are equal. Y effective is equal to Y1 plus Y2 by 2 whenever parallel connection is there. And this is important. The length of the metal wire of length L1 and tension T1, length L2, tension T2, then actual length L is equal to T2 L1 minus T1 L2 by T2 minus T1. A ball of mass M is attached to one end of a wire of length L, area of cross section A, and negligible mass is kept on the smooth horizontal table with other end fixed. If it is rotated with angular velocity omega, when the extension of the wire is E is equal to ml square omega square by AY. A stone of mass M is attached to wire of length L, cross section area A. The stone is rotated in a horizontal plane, then E is equal to mgl by AY cos theta when the stone makes an angle theta with the vertical. So at different places, different elongation you can expect, because what you call gravitational component is going to change. That will be better. Next, elongation of the wire due to its own weight. Suppose heavy wires are suspended, then because of its own weight only it is going to be falling down. In that case, E is equal to L square dg by 2y L square dg by 2y. Effective length will be taken in this case is L by 2 because its own weight will act from the center of the wire. Elastic moduli, rigidity modulus. Rigidity modulus denoted with eta. It must be pronounced as eta. And within the elastic limit, the ratio of shearing stress to the shearing strain is called rigidity modulus, and the picturization, that means shifting of lateral shifting of the layers, is rigidity shearing, that means shearing strain that causes. So eta is equal to f by a theta or f by a by tan theta or f by a by sin theta when theta is small. This is torsion, shifting the layers, torsion. L phi is equal to r theta, where L is length, phi is the angle of shear, r is the radius, theta is the angle of twist. Twist, shear. I think I typed here. Let me check. Yeah. Work done on the rod is half tau theta. Couple per unit twist is C is equal to pi eta r to the power of 4 by 2L. Energy stored is half C theta square, couple per unit twist into theta square. So bulk modulus or elasticity. Bulk modulus. Different moduli we are discussing. Bulk moduli. Bulk moduli is normal stress by, that means volumetric stress by volumetric strain. Bulk modulus. Some books contains B, some are K. Both are same. This is always negative. Minus delta P, increased pressure or changed pressure, into volume by change in volume. Change in volume here always a depressional or compressional. So negative will come always. And bulk modulus for solids is larger than gases. And compressibility is the reciprocal of bulk modulus. More the K value, lesser the compressibility. When a rubber ball of volume V is taken to a depth because of the increased pressure, its volume decreases. That change in volume is given by H rho G, increased pressure, into volume by bulk modulus. Excellent formula. These are all practice on the paper. Isothermal bulk modulus of gases is P is equal to pressure. Adiabatic bulk modulus of gases is gamma P, gamma equal to Cp by Cv. And decrease in density of an object of initial density rho and pressure P is applied from all the sides, then increased density equal to original density into pressure by K minus P. And Poisson's ratio, excellent ratio it is actually. Poisson's ratio is the relation between lateral strain to longitudinal strain. So comes to that lateral strain by longitudinal strain is sigma, that is called Poisson's ratio. Sigma equal to minus delta R by delta L by L. Theoretical limits of sigma is minus 1 to 0.5, but practical limits are 0 to 0.5. And fractional change in volume is equal to fractional change in length into 1 minus 2 sigma. This is the relation between length change and volumetric change. If it is 0.5, then fractional change in volume will be 0. Relation between all the moduli along with the Poisson's ratio is, nowadays some questions are coming on this. 9 by y is equal to 1 by k plus 3 by eta. You need to memorize because derivations are higher order. So memorize you need to, and takes a lot of time. Y equal to 2 eta of 1 plus sigma and y equal to 3k of 1 minus 2 sigma. Sigma equal to 3k minus 2 eta by 6k plus 2 eta. Everything can be derived but time consuming, so you need to memorize. And work done in increasing the length of the wire is given by half YA by L into E square, or W equal to F square L by 2AY, half FE. This is the work done in increasing or in changing the dimension of the body. Next, strain energy per unit volume is given by U is equal to E by V equal to half stress into strain, or stress square by 2Y, or half strain square y. So three formulae. In this three formulae, in one formula there is no y, in another formula there is no stress, in another formula there is no strain. If the force on the wire is increased linearly from F1 to F2, then energy stored in the wire is E equal to E of half F1 plus F2 by 2. And this is Y alpha delta theta. Thermal stress developed is Y alpha delta theta. And thermal force Ya alpha delta theta, that also will be followed. Thermal force is Ya alpha delta theta. It developed if and only if the body is fixed between rigid supports and heated. then only you can observe. Fixed between, that is important. If you put a rod free and if you heat, there is no thermal stress. If you fix between two rigid supports and if you heat or if you cool, then it comes. In cooling also it comes. A string is taut between two fixed points, and if you cool the string, then also thermal stress will come. These are the things, miscellaneous points. Depression of the beam is delta is equal to WL cube by 48 YI. Actually, it is breadth actually. Okay. So WL cube, weight, length, 48 Y and breadth. Okay. Next, for cantilever beam depression, delta is equal to WL cube by 3Iz, and where Iz is the geometric moment of inertia. Okay, in that automatically everything will come. And rectangular cross section Iz is equal to BD cube by 12, and for circular cross section Iz is equal to pi r power 4 by 4. Torque required to produce a unit twist in solid shaft tau is equal to pi eta r power 4 by eta. Torque required to produce a unit twist in hollow shaft is pi eta r2 power 4 minus r1 power 4 by 2L. And these are the important formulae, of course majority formulae related to mechanical properties of solids. And we are going to discuss numerical problems and varieties of questions in the worksheet discussions, right? Keep on learning all the formulae. We will start doing worksheet questions in the next session. Bye.